from the day 1 till last session. So the chapter electric charges and field is all about how to find the electric field. Believe me, the core of this chapter lies in electric field concept. And I told you what is electric field. Before that, I taught you about what is a charge and how is charge creating electric field around it. The first topic in this chapter was basic properties of charges, which are 3: additive nature, quantization, conservation. I even taught to you what is the meaning of each thing and how the questions are being asked from these topics. Then I taught to you what is Coulomb's law of electrostatics, that is attraction or repulsion, where the law says that every two charges, charged bodies, not any bodies, charged bodies will either be attracted or be repelled by a force which is directly proportional to product of their charges and inversely proportional to square of distance between them. And when we write about that, we will write F is proportional to Q1 Q2 by R square. So F is equal to K into Q1 Q2 by R square, and that K is what? Not K is not permittivity. K is 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of free space. K's value is obviously a constant, 9 into 10 to the power 9, and epsilon naught value is also constant, which is 8.85 10 to the power minus 12. That is the value of epsilon naught, permittivity of free space. Now, if you have some other medium, then permittivity will change. The meaning of permittivity is permission given by the medium for the charges to interact. If the permission given by the medium is more, then the more force will be there. If the permission given will be less, less force will be there, right? So the force of attraction or repulsion is not only depending upon the charges and the distance between them, it also depends upon which medium charges are placed. Unlike gravitational force, which was not medium dependent, whether two objects are in space, in some medium, in anywhere, the force of gravitation remains same, and force of gravitation is only attractive. But electrostatic force is attractive if charges are unlike and repulsive if charges are like. Isn't it? Then I talked to you about how to use Coulomb's law in vector form. If you have only two charges, then yes, we can use K Q1 Q2 by R square and find the force between them. But if they have 3 charges, 4 charges, then how to deal with the force? Then we will come to the vector concept, where we will find force 1, force 2, then the resultant force will be root over F1 square plus F2 square plus 2 F1 F2 cos theta. The most used theta in physics is 120 degree. Remember, cos 120 minus 1 by 2. I am not saying that will only be there, but most commonly used. And then we learned about electric field, which was electric force experienced per unit test charge. F by Q naught is called as electric field, and electric field SI unit is Newton per Coulomb. Force by charge, Newton by Coulomb, so Newton per Coulomb, isn't it? Then I spoke to you about electric field due to a point charge, and its value is KQ by R square. So E is equal to KQ by R square, where you can find electric field due to any charge at R distance away. So you can see that electric field is inversely proportional to R square. So the more far you go, electric field will keep on reducing for a positive charge and opposite in the case of negative charge, right? Then I talked to you about electric field due to multiple charges, and I said same thing, like electric force, whenever you have multiple charges and you want to find the electric field due to multiple charges, you should use vectors. And the place where you are finding electric field, a test charge has to be placed. Test charge is an imaginary charge having magnitude 1, a positive value. So there you will see this charge will be attracting, repelling. Like that you will draw the electric field directions and solve by using vectors. You will be able to get the net electric field at a particular point. Then I told to you, questions from electric field will come in this category. One category is finding the point at where the electric field is 0. Two charges are there, between them or outside them. If they are like charges, that is plus plus or minus minus, then between them electric field can be 0. But if they are unlike charges, then nowhere between them electric field can be 0. You have to go outside the charge for finding the electric field to be 0. Then I taught to you about dipole, and I told dipole is an arrangement of two charges having equal and opposite signs. That is plus q, minus q, small separation. Small separation I took as 2D, and I told you 2D is having no significance other than helping in derivation. If 2D would have not been there, D would have been there, then it will become R plus D by 2, R minus D by 2, and it will become little tedious to solve. But I am not saying you cannot solve, you can. And then we found what is the meaning of electric dipole moment, which talks about the strength of electric dipole. P is equal to Q into 2D, and its SI unit will be coulomb meter, isn't it? And its direction is from negative to positive, it's a vector quantity. And then I found what is the electric field due to electric dipole at an axial point, which was equal to K 2 Kp R by R square minus D square the whole square. This is the value of electric field due to electric dipole at an axial point. If R is much more than D, then electric field was equal to K into 2P by R cube. Then I taught to you about electric field due to electric dipole at an equatorial point, and the value is K into P by R square plus D square power 3 by 2. If R is much more than D, then K P by R cube. E axial is 2 times E equatorial for R being much more than D. Then I taught you behavior of dipole if it is kept in electric field. If electric dipole is kept in uniform electric field, it will experience a torque, and torque will try to rotate it, align it with direction of electric field, and torque formula is Pe sin theta or P vector cross E vector. So theta decides how the torque will be. If theta is 90 degree, torque is maximum. Theta is 0 or 180, torque is 0 minimum, isn't it? Then I told to you, if a dipole is placed in non-uniform electric field, then it will experience a translatory force in addition to rotational force, which will make the dipole to move even some distance along with turning. So if it is kept like this, it will move like this. If it is only uniform electric field, it will just rotate from its position like this. But if it is electric field which is non-uniform, it will go like this. So it will have translatory force in addition to rotational force. Up to here we have seen in the previous class, and today if you cooperate and if everything goes fine, we will be putting a full stop on this chapter. Okay. So let us start today's class, and today's first topic is electric flux. But before I talk about electric flux, okay, let me talk about electric flux itself first. So give the heading as electric flux. Yes, man.
Sir, it's not there.
Did you meet Alamilima?
She wasn't there. And then when we asked another teacher to call her, she wasn't picking up.
She's above. Opposite room you go and see. Just opposite room. Last man, then we can come inside. Okay. And even some students are there. Sorry. So let me ask this to Anshul. What is the meaning of the word flux? Have you heard this before? Flux? First time hearing. Kavya, any idea what is the meaning of the word flux? Loudly once again, please. Fluids, you are saying.
No, sir. Flux means when something is breaking from uniform to non-uniform.
Something is breaking from uniform to non-uniform. Okay, fine. Harvish, any idea about the word flux?
It is like a reference point or simply a point, sir.
Okay. Yes, Sharan Ram. Flow. Okay. So, Nikhil, any idea? No? Shweta, any idea? No? Okay, they can see the video issues. Yeah. So, next is Mr. Niranjan. Have you heard the word flux before in your life?
Yes.
What is the meaning of flux?
Something to do with electric field.
No, we should not say like that. That's to do with electric
So
field.
that's all I know.
I'm not asking about electric flux. What is a flux? I'm asking you.
Like state of change.
State of change. Okay, fine, fine. Please take your seat. Yes. So, flux, if I remove, loudly Pratap.
Is it flowing out or flowing just flowing? Flux means flowing out and flux means flowing right.
Okay, okay, okay. I get your point. Flux is definitely flowing of something. Not only flowing, flux is flowing as of something through a given area. Sorry. For example, if you have a window in home and air is flowing through it, we will say air flux. If you have an opening and water is flowing through it, it is water flux. Are you getting my point? If you have electric field flowing through an area, that is called as electric flux. Are you getting my point? Write definition first. It is the electric field lines, all of you please write. It is the electric field lines. It is the electric field lines passing normally through a given area. Passing normally through a given area. When I am saying normally, it is not the English word normal. Normally means 90 degree, perpendicular. Okay. So it means that if you have a particular area and there are some lines passing perpendicular to it, electric field lines, this is known as electric flux. And electric flux is represented by this letter phi. Phi. Okay. Phi E some books will write, because there is something called as magnetic flux also. So phi E means electric flux. Okay. So what is electric flux? Electric field line. These electric field lines. Electric field lines passing through a area. That's all. Simple. Now I'll tell one more thing to you. Write that mathematically, phi is equal to E vector dot A vector. Phi is equal to E vector dot A vector, where E is the electric field and A is the area vector. A is area vector. Let me brief about this to you. Whether area is scalar quantity or vector quantity? Area is definitely scalar. Obviously scalar only. I am not talking about area, phi, man, I am talking about area. Area generally is scalar quantity, right? But here I am using the word area vector. Doesn't it sound strange? Because area is scalar, length is scalar, volume is scalar. Area is scalar, I am telling you. Then how suddenly I am writing area vector? What is the meaning of area vector? How area became vector quantity? Area obviously the scalar quantity, but if a given area is represented with a direction, it becomes vector. So for a given area, this is area vector. Are you getting my point? This is the area, this is the area vector. Are you getting my point? So area vector is perpendicular to the area. Are you getting my point? So in this case, in this diagram that I have drawn, if I draw area vector, you know how it will look like? It will look like this. This is the area vector. So electric field and area are parallel here. Do you agree with me? Electric field and area are parallel here. You may think it is perpendicular. You may think that area is there and electric field lines are there. So electric field lines are perpendicular to area. You may think like that, isn't it? But here electric field lines are parallel to area vector, because area vector is perpendicular drawn on the area. Don't get confused. It's very confusing if you don't understand. Generally what we think, this is the area, This is the electric field. So electric field is perpendicular to area, isn't it? But when you do a numerical, they will take theta as 0 degree. Why 0 degree? Because it is not the angle between electric field and area. It is the angle between electric field and area vector. And area vector, I am writing it here, it is perpendicular to area. I will write like this. Perpendicular drawn on area. I hope you are getting my point. So if you know A vector dot B vector is equal to AB cos theta, isn't it? So here I will write phi is equal to mathematically E A cos theta. This is the magnitude of electric flux, E A cos theta, where E is the electric field, A is the area vector, theta is the angle made between what and what? Electric field and area vector. Got my point? Are you getting my point? Yes or no? Understanding? Very basic thing. And believe me, expect a question to come from this concept in board exam itself. Electric flux is something like sure question in board exam. Not from here, I will go deep, just the introduction. But yes, this topic is very important for the board examination, electric flux. Is it clear to you what I have written here? E A cos theta, E is the electric field, A is the area vector, theta is the angle made between electric field and area vector. What will be its SI? First of all, whether flux is scalar or vector? Obviously scalar. Dot product of two vector quantities is scalar. That's why it's called a scalar product, isn't it? So it is a scalar quantity. Electric flux is a scalar quantity, and what will be its unit? Electric field is Newton per Coulomb, area is meter square, so SI unit will become equal to Newton, yes, Newton meter square per Coulomb, isn't it? I hope it is clear to you. Very basic things we are talking. Shall I go ahead? Move forward? Okay. Now, if I ask a question, shall I ask a question to you from here now? Very basic question, shall I ask?
Yes, sir.
Yes. So, let me assume there is electric field like this. Uniform electric field is there, having value E vector. Mind my words, uniform electric field. In this uniform electric field, I am placing one cube of side length. Let me give it as a question. So electric field is 20 Newton per Coulomb in this direction. Which direction? X direction. And then this cube is having side length of 1 meter. So 1 meter by 1 meter by 1 meter cube is there. If I ask you, what is the net flux through the cube? What will be your answer? Is my question clear? Question is, if it would have been one phase, you can very easily do, you will say that E into A into cos theta, theta is 0 degree here, E is 20, area is 1 into 1, 1 square, so 1 into 20 is 20, flux is 20 Newton meter square per Coulomb for one area, one surface, but I am giving you a cube, 6 side cube, and you have to tell me what is the flux through the cube? Closed? Yeah, cube. Imagine like a Rubik's cube. So how much is the value? To prove it mathematically, not theoretically. Is the question clear to you? 40. Okay. One answer is 40. Yes, Pratap.
So 40, sir. Even I go with 40.
40.
40, sir.
Okay, Shaktivil says 40.
Sir, the electric field is passing through which part of the cube?
Imagine in this room, we have electric field like this, going from this wall to this wall, and cube is kept here. in between the electric field. Cube, I hope you are understanding how the cube is. Are you getting? So this face and this face it is cutting and going.
Like in the middle or
Throughout. Yes. 40. Okay. I have got 3 people saying 40. 3.33. Some person saying 3.33. Yogit saying 3.33. Anybody else? Give a try. Right or wrong is secondary. I am not going to give any prize or not going to give any scolding for wrong. Neither toffee for right. 80. Okay. I have 3 answers now. 40, 80 and 3. Deva, tell me loudly. 120. It is increasing. 40, 80, 120. Huh? Auction is going on. Yes. Now somebody will say 500. Yes. Anybody? Any answer? No? Nankil, no try? 80. We'll go with 80. Niranjan? No risk. Shall I say the answer? Who is the winner in this contest? I am the winner. No, all of you are wrong. The answer is 0. Answer is 0. I thought of saying 0, huh? I'll explain, man. I'm not saying 0 and I'll go to the next topic. I'll explain you. Why are you worrying? Pay attention. Important. Please. First of all, whenever any question of electric flux and a surface or a volume inside electric flux is given to you, electric field is given to you, always remember you have to check all the area vectors. So there are 6 surfaces here, isn't it, in a cube? So let me try to make it visible to you. This surface, above surface, will have area vector like this. I am writing it as A1, right? Vector I am using. Then below I am writing A2. Towards left I am writing A3. Towards right I am writing A4. Behind I am writing A5. And towards you I am writing A6. Is it clear to you, all the 6 area vectors? If I have a cube here, A1, that is 1 here, 1 below, 1 towards me, 1 towards you, 1 left, 1 right. Clear? All the area vectors are clear to you, visible? Yes. Now, the flux through each area we will try to find. So, first area, what is the answer? E A cos 90. Do you agree with me? Because electric field towards right, area upwards, angle between them 90 degree. Good. Plus E A cos, I am talking about second, down, 1 second perpendicular, 90, plus E A. Third area is this side. Area vector towards right, sorry, electric field towards right, area opposite direction. What is between them the angle? 180 degree. So EA cos 180. Kavya, your video is off. Who is this Yokesh MD? Can you please unmute yourself and on your video?
Yeah, sir. Just today I have joined this one.
Very good, Yokesh. Who gave that timing to you as 7:44?
Yeah, sorry for the date.
Okay. So what shall we do?
Yeah, so what chapter you are talking about, sir?
I am talking about electric charges and field.
Yeah, okay.
Okay, shall I continue? Mr. Yokesh, if you allow me, I will continue. Okay, plus fourth area towards right. So it will become E A cos how much? 90. Electric field here, area here, 0. Plus 5 is behind. This is the electric field behind, again 90 degree. So E A cos 90. And last area towards you, once again perpendicular, E A cos 90. What is cos 90? Thank you, you know 0, 0, 0, 0. What is cos 180? So minus EA, what is cos 0? Plus EA, what is the answer? Got it? Why the answer is 0? You thought A3 and A4 in same direction. They are opposite faces. They will have opposite direction, isn't it? Cube, 6 faces are perpendicular to the electric field, not faces, area vectors. A1, A2, A3, A4. 4 faces are perpendicular. So they are anyhow going to have 0 electric flux. 2 faces are only parallel or anti-parallel. So cos 0 in this direction, cos 180 is in this direction. They will also cancel each other. For your information, any symmetric object, any object for instance, if it is kept in uniform electric field, flux through it will be 0. You know why? Because total electric field entering and total electric field exiting are same, electric flow is going to be 0. Applicable only for uniform electric field, mind my words, not a non-uniform electric field. If electric field is uniform, then any shape kept inside will give 0 electric flux. For example, if I would have given a question like this to you, that there is an electric field, and in this electric field, uniform electric field, I am going to place a cylinder, any direction you can give like this. And if I ask you what is the net electric flux through the cylinder, then what you will do? Once again, there are 3 areas possible here. One area is towards right, A vector, A1 vector. One area is towards left, A2 vector. And third area is perpendicular. Wherever you keep it, like this, 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 it is always perpendicular to what? Electric field. So flux through this face is obviously going to be 0. This will be EA cos 0. This will be EA cos 180. So plus EA minus EA 0. Logic is clear to you? Logic is flux entering, flux exiting are same. That way you can think. Or you can find for each surface and check. Is it clear to everybody? One more way you should think. See, if you see this particular case, we had 6 cube faces, isn't it? And if you see the 6 cube faces, the number of electric, okay, same thing I told you, electric field lines entering, electric field lines exiting, they both are going to be same, so net electric flux is going to be 0. Is it fine? Clear to everybody? Okay. Then if you want to write something, you can write, then I will give the next topic heading. I am giving 1 minute time to you. If you want to copy something, please copy. Yes, please.
Place a sphere there.
Yes.
Direction will the area vector point in?
Good. So suppose you have uniform electric field, and as you said, I am keeping a sphere inside. So sphere will have all directions electric field, that is area vectors, right? You may say that, sir, some area vector may not be perpendicular, may have some angle. What I will do for your understanding, I will divide the sphere in 2 parts. One part is having like this, another part like this, isn't it? So for this part, the electric field in this direction and area vector will be having different values, and for this part, area vector will be exactly opposite to that. So whatever flux produced here plus direction will be balanced by minus direction, value will be 0 only. Got my point?
So will you be learning about non-uniform electric fields?
Yes, I
Electric flux?
am going to talk about that next. We have a question in NCERT book also. We will take that for example and solve. Shall I proceed ahead? If you permit me, shall I? Anybody wants me to wait? I can go ahead, right? Okay. Now let us talk about electric flux through non-uniform electric field. Electric flux through non-uniform electric field. Right. So now what will happen? Please pay attention, I will give time for writing. What they will do? They will give you a condition like, for example, electric field is varying or is non-uniform, and it is given by an equation E vector is equal to alpha x I cap Newton per Coulomb, alpha x I cap Newton per Coulomb. If a cube of side 2 meters is placed in this electric field, as shown in figure, calculate the net electric flux. Is it clear to you? This is the question. Here they will write alpha is equal to 100. You know why this question has been framed? This question has been framed to make you afraid. Alpha, x, I cap, by seeing these three letters, symbols itself, you will give up. Many of you will give up, I know. If I would have written 20x, no, you will be having some confidence. I removed 20 and wrote alpha, you got fear. Something is fishy in this question. That is the general behavior of children I have seen. Again, if I don't write I cap, they will be having some confidence. I add word I cap, something is going to happen. These things are fearing you. It's nothing. It just says that alpha is 100, right? 100 x I cap means in x direction. So electric field is changing in which direction? In x direction. And what is the variation? 100x. That is, if I am going 1 meter, it is 100. If I am going 2 meter, it is 200. If I am going 3 meter, it is 300. Are you getting my point? Alpha is fixed 100. If I am going x is distance. So if I am going 1 meter apart, electric field value is how much? 100 into 1. If I am going half meter apart, 50. If I am going 20 centimeter apart, 20. Am I right? So based upon how much far you are going, the electric field is varying. At origin, it is 0. Because electric field is, if x will become 0, it will become 0, isn't it? So in this case, what they will see, I will draw a diagram for you. Like this the question is, and they have told a cube is placed here. Or let me draw little better diagram. Okay. Now this cube is having side of 2 meter and is placed 1 meter away from the origin. Okay. This cube is placed 1 meter away from the origin. Can you try and to find the value of phi? Give a try. I will help you if not. Please give a try. If you are understanding this question, please give a try. Logic I have told you, yes, 200. Too quick, so it has some probability of being wrong. I am not saying you are wrong, but probability is there. Think. We are very sure that this area, down area, towards you, away from you, is going to give 0. Yeah. Okay. One more 200 came supporting Shweta Shinde. Today your partner Karthikeyan is not there. Yes, Yokesh MD. Coming late.
Yes, sir, back.
You're back. Thank you for being back. You wait at 9 PM. Okay, I want to speak to you, man.
Yeah, sure, sir, I'll be there. Sorry, sir.
Yeah. So, shall I help you in solving? I have two answers from your side. One is, both are 200. Anybody else wants to give some answer? Or shall I solve it? 800.
Sir, can it be 0?
0 it can never be, but anyhow, Deva, please tell me. 0 only you are also saying, okay. 0, 2 answers, 800, 1 answer. You are to 200 sticking, Niranjan, or changing your value? 200, okay, sticks to 200. Yes.
You do that green arrows, sir.
Sir, actually I'm saying my answer.
Ha, please, Sharan.
You do that.
Green arrows, yes.
Those are finding a front and back are.
Oh, you have that vision problem. One is top, one is bottom, one is towards you, one is away from you. Nothing right, left, I have not drawn yet.
Sir, 8.
Okay. So now 2 or 800, 2 or 0. Anybody else wants to give any answer? No? Shall I solve? Listen carefully. This kind of question is there in NCERT book also. I will give you that as a homework, but understand how to solve this question. Please pay attention. All of you, attention here. Yes. So, as I said, these 4 green arrows are definitely not going to produce any flux, because they are perpendicular to electric field. Cos 90 is 0. That much trigonometry we know. This face is going to have area vector in this direction. Do you agree? And the opposite face is going to have area vector in this direction. That's correct. They are opposite. But whether electric field is same at both points? No. Here the electric field value is, I am writing it as E1. E1 is equal to alpha is 100, x is 1, I cap, whatever. And what is the electric field here? 1 plus 2, it will become 3. Isn't it? 3 meters. So it will become E2 is equal to 100 into 3 into I cap. Do you agree with me? Do you agree with me?
Yes, sir.
I'll come. Why E1 is going to be negative? 5 is only going to be negative. E is in this direction only, plus x. E will not be negative, positive. Phi will be negative as you are thinking. So now I am going to write net flux phi net, which is the summation of phi 1 plus phi 2. And what is phi 1? I am taking this as 1. So phi 1 will become equal to E, which is 100, into area, which is 2 square, going to be 4, into cos 180. Do you agree with me? Because electric field towards right, area towards left, angle between them 180 degree. So cos 180 is minus 1. We'll come to that. Plus, what is phi 2? 100, not 100 actually, 300. 300 into 4 into cos 0. Do you agree? Do you agree?
Yes, sir.
So what is cos 180 minus 1? So minus 400 plus 1200. How much is going to give you? 800 Newton Coulomb inverse meter square. This is the value of electric flux. Correct, good. Are you getting how the answer has come? Here electric field was non-uniform. So it will have a different value at this phase and different value at this phase. And how I have solved, is it clear to you? Very similar question is there in NCERT book. If you have the book in your hand, then the question number is probably example 1.10, page number 31. If you see, you will realize a similar kind of question is there in your book also, in NCERT book also, right? I hope it is visible to you, this question, isn't it? So today you do this question as a homework, not now. Now you can solve it. Very similar question. Ex is equal to alpha x power 1 by 2. They more complicated. You are afraid of power, they gave power also. So they gave electric field as alpha x power 1 by 2. It means alpha root x, I cap, isn't it? I cap not given. Ey is 0, Ez is 0. Alpha value is given to you. And they are asking what is the flux through the cube. I hope you can solve this by yourself now, isn't it? So we will do it as a homework, and I will proceed here in the chapter. Shall I proceed? Shall I proceed? Next topic. So next topic you give as the heading as Gauss law. If you want some time to write this, shall I wait for a minute for you people? I'll wait. Some people need, I think, time. I'll wait for 1 minute and then I'll proceed. Please copy if you want to copy something. Make it fast, please. I'll wait for a minute. Shall I proceed?
Yes, sir. Yes.
Thank you. Now, the last topic of this chapter, very important topic of this chapter, the heading is Gauss law. Gauss law. First you write the statement, then I will give explanation to you. Shall I? Right. Electric flux through any enclosed surface, electric flux produced by a charge, electric flux produced by a charge, in bracket you can write, or charges, electric flux produced by a charge, in bracket you can write, or charges, through any enclosed surface, through any enclosed, E-N-C-L-O-S-E-D, enclosed surface. Once again in bracket you can write Gaussian surface, Gaussian surface is 1 by epsilon naught times, is 1 by epsilon naught times the net charge enclosed, the net charge enclosed, net charge enclosed. I will explain this to you now, please pay attention. Up to now we know that electric flux phi is equal to E vector dot A vector, am I right? General formula, general definition, general understanding of electric flux. What did Gauss do? Gauss gave another way of calculating electric flux for what? For charges, single charge, 2 charge, 3 charge, or multiple charges. For multiple charges or for a system of charges, he gave a way of finding the electric flux. And what did he say? Suppose you have some charges, suppose Q1, Q2, Q3, Q4, then what you do? You enclose all these charges by using an imaginary surface. It can have any shape, cylindrical, cubical, spherical, but the condition is it should enclose all the charges. And this surface he called as Gaussian surface. So what is Gaussian surface? Gaussian surface is an imaginary surface. It is not real, it is imaginary. It is imaginary surface which is used to enclose the charges. If spherical surface is enclosing, use spherical. Cubical is enclosing, use cubical. Cylindrical is enclosing, use cylindrical. Whatever surface is helping you to enclose the charges, that surface is called as a Gaussian surface. Is it clear to you? Imaginary. Don't say, sir, if I am taking spherical, my friend is taking cylindrical, whether we will get separate answer? No, same. I hope you are getting a point. It should just be an enclosed surface, need not to be a same surface, need not to be only a spherical surface, only a cubical surface. It can be any shape. It can be of any size. Sir, I drew a sphere of 1 centimeter radius. My friend has drawn a sphere of 2 centimeter radius. Whether flux will be different? No, it will be same. So, electric flux is independent of the shape of the Gaussian surface, independent of the size of the Gaussian surface. Are you getting a point? It just depends upon net charge enclosed. And as per Gauss law, this flux is equal to 1 by epsilon naught times the net charge enclosed. This is only called as Gauss law. So, Gauss law says that phi, which was already given as E vector dot A vector, is also equal to Q by epsilon naught, where Q is the net charge enclosed. Be very careful. Net charge enclosed. I will tell you how it is very useful. But write this mathematical expression also fast. Obviously 3D only, man. Charges are 3D, right? Charges cannot be 2D. Theoretically we can draw, but practically it will be always a 3-dimensional object, not object, particle. Isn't it? Can I proceed further?
Just a minute, sir.
Net charge? Charge is scalar quantity. You will use vector on that. Yes, then what? What is additive nature of charge says? What does additive nature of charge says? Property. The net charge on a body is algebraic addition of all the individual charges, right? Did you take the notes when I taught this topic? You have it in your notebook now? Some new notebook you are using today? Very good, Shweta. Next class I will ask ma'am to check the notebook. First class I taught this only, no? Properties of charge. One property was additive nature. It says that net charge on a body is algebraic addition of individual charges. Got it? So, it is a scalar addition only, not vector. Can I proceed? Can I show you how important is Gauss law? Shall I? Okay. Once again, NCERT has this question. What I am going to do now, in exercise this question is there, and in competitive examination it is very much used. What I am going to teach now, actually this concept is not there in NCERT. Any page you will not find what I am going to teach now. It is a competitive class topic. Then why I am teaching in this batch? I can teach this on Sunday batch. Why I am teaching in the regular batch? Because even though this topic is not given in NCERT book, there are questions coming in the board exam as well as in the same book exam exercise question is there, where you have to use this logic. Okay. So, now what we are going to learn, give the heading as electric flux through a cube. Electric flux through a cube for a given charge placed inside it. Placed inside it. Very logical thing we are going to learn. This is actually there in competitive section. Let us learn this. Shall I? Okay. So, first condition. I have a cube and I am placing my charge in the center of the cube. Clear to everybody? I have a cube and I am keeping my charge where? In the center of the cube. You can imagine this room itself. This room is like a cube only, kind of. Top, bottom, left, right, front, back, like a cube. Cuboid also it can be. And I am placing charge in the center of this room. If I ask you, what is the net flux through it? What will be your answer? Charge Q is placed inside the center of the cube. What is the net flux through the cube? Why q by 6 epsilon? Don't try to be over smart. Don't go to the next topic. Be clear. Don't try to remember something and answer. Q epsilon naught. Draw Gaussian surface. If you draw Gaussian surface, enclosing how much charge? Q only, no? Common sense says that the answer is Q by, that is the answer. If I ask you, what is the flux through a particular face, that is Q through each face. Now what you thought and remembered is the answer, Yogit. 1 by 6 times of Q epsilon, isn't it? Why? Because there are 6 faces. Each face will receive same amount of flux, no discrimination, because the charge was placed in the center of the cube. Here, here, above, below, towards me, towards you. All faces will receive same flux. So each will divide equally. How many faces are there? 6 faces in a cube. So how much flux each face will receive? 1 by 6 times of Q by epsilon. Do you agree with me? Do you agree with me? Now, let me little complicate it. I will complicate it by adding the same charge, but now where I will keep the charge? Corner I will come later. I will keep it the middle of the face. So there was a cube. Earlier I kept the charge in the center of the cube. Now I move the charge towards one of the face. Are you getting how where the charge is? And then if I ask you, tell me, what is the flux through the cube? What is the flux through this cube? Q epsilon naught. Very good. It's wrong.
2 by 6 epsilon.
Q by 6 epsilon naught for the cube. No, Deva, think a bit more. First of all, understand that this charge will release some. See how, what is the meaning of charge kept? Charge will produce electric field lines, isn't it? You know that a point charge, if a point charge is there, how the electric field lines will be? Radially outwards. Very good. Like this, isn't it? Radially means 3 dimension, every side, not only in a 2 dimension, not in a circle, like a sphere it will be. Spherical shape will come of the electric field. Now, if it was in center, I can feel like yes, going equally in all directions. If it is in one of the faces, then don't you think that out of whatever flux, water electric field lines it produce, only half will go here, half will go this side? I mean to say that you need to place an extra imaginary cube here to make it symmetric. Yeah. Isn't it? Or it became symmetric? Now these 2 cubes together will have Q epsilon naught. So 1 cube will how much? 1 by 2 times of Q epsilon naught. Do you agree with me? 1 by 3 how, man? 1 by 2. 2 are there, no? So 1 by 2. Please understand this logic. 1 cube, charge in center, Q epsilon naught. If I am keeping charge in one of the faces, I must have another cube to make it symmetric. So both the cube together is going to have Q epsilon naught. 1 cube will have only half of it. So 1 by 2 times of Q epsilon naught. Is it clear to you? And then if I ask you, what is the flux through each face, what would be your answer? Think and say, man. 2Q, how it will come? See, this cube is having cube have 2. And now how many faces this thing has? 6 faces. But in the 6 faces, this face will not be considered. You know why? There only charge is present. If I am present here, I am releasing the flux. I am sending to all directions except this direction, right? This face, right? So 5 will be there. Going to be 5 means 1 by 5 times of 1 by 2 times of Q epsilon, isn't it? The answer is 1 by 10 times of Q by epsilon naught. Are you understanding this? Very important logic I am teaching now. It is not there in NCERT book. I will tell again, no problem. What I said, when the charge is placed at one of the faces, I need to bring another cube to make it symmetric, right? So the net flux through both the cubes together is q by epsilon naught. So one cube will get 1 by 2 times of q by epsilon naught. Now since the charge was present in one face, like for example in this room, this is one face, and charge is going to release the electric field lines in all directions. So I should not take 6 sides, no yaar. One side I am itself there. Only 1, 2, 3, 4, 5 side I am going to throw the electric field lines. So 1 by 5 times of q by epsilon naught. Q means q by 2 epsilon naught. So it will become 1 by 10. Are you getting, Deva? If I tell in simple way, layman's way, which everybody will understand, whenever you are finding flux through each cube, Nikhil, pay attention. Whenever you are finding flux through each cube, don't consider the side or the sides in which your charge is attached. Layman's logic. I will repeat this. When you are going to find the flux through a particular face, don't consider the number of faces in which charge is connected, charge is placed. If it is placed in the one face, I am not considering one. Suppose this charge would have been kept in the corner, then these 2 I will not consider. If the charge would have been placed in the vertex, 3 I will not consider. I will repeat. It is confusing. Cube is there, and in this cube, if the charge is going to be placed in one face, then this face will not be considered, right? If the charge would have been placed in one of the corners, then see, this face as well as this face is going to get affected, isn't it? So only 4 faces will be considered. If I am going to place the charge at one of the vertex, like here, then 3 surfaces, this one and the above one will not be considered. Only 3 will be considered. Do you get my point? This logic also, if you remember, you will understand why I am taken 1 by 5 times here. Because it was in one of the faces, only 5 I am considering, leaving that one face where the charge is already present. Is it clear to you? If not also, with time it will become all right. Have faith on yourself, on me. We will make it all right, don't worry. Shall I proceed further? Please ask me.
Sir, the charges on the vertex, sir, we are adding 7 more extra in
Yes, good, very good, yes. So it will become 1 by 8 times of q epsilon naught. Got the logic? You are done now. So can you go to the next third condition? Third condition is I am going to place the charge where? I am going to place the charge in one of the edges. First was center, second was face, third is going to be edge. If you are going to place on edge, how many cubes you need to make it symmetric? 4 means 3 more. 3 more extra you need, isn't it?
Yes, sir.
Yes. So 3 more extra like this, one behind this and behind this. I hope all of you are understanding what we are doing, isn't it? Now this charge became symmetric. So what is the flux through each cube? Flux through each cube will be how much? Tell fast here. Cube I am asking. 4 are there, so 1 by 4 only, no? This much time you are telling to say the answer. In the previous case, I had 2 cubes, so I took 1 by 2. In this case, I had only 1 cube, so 1 by q epsilon naught. Here I am having 4 cubes, so each cube will get how much? 1 by 4 times of q epsilon naught. And what about the flux through each face? Very good, 1 by 16. Because if I keep here, this face and this face will not be considered. Only 4 will be considered. So 1 by 4 times of this value, which is 1 by 4 times of 1 by 4 q by epsilon naught. The answer is 1 by 16 times of q by epsilon naught. Understand the logic? Actually, we are in competitive level now for this kind of topics. It is not there in NCERT. I am repeating multiple times. Please ask Kirti.
Why is it 1 by 5?
This one. Yes, I said when you are having a particular charge at a particular location, make sure it is symmetric. Now it is not symmetric because it is going to release some flux here, some electric field this side, isn't it? Right, Kirti? If you want to make it symmetric, I want to add how many? You want to add totally, I am drawing with a different color, 3 more cubes. Pay attention here. If I am drawing one cube here, another cube here, now it became symmetric. It came in the center of all the 4, right, Kirti? So only a total flux is q epsilon naught through the all 4 cubes. A particular cube will get how much share? 1 by 4. So what I am doing in each scenario, first I am checking whether the charge is symmetric or not. In the first case, it was by default symmetric. So I had not added any further cubes. In second case, it was not symmetric. I needed one more cube to make it symmetric. In third case, it was unsymmetric. I needed 3 more cubes to make it symmetric. Now when I am going to place, the same charge where? At one of the edges, yes, corners. See what is going to happen. What man? Yes, obviously 7 cube, Deva, as you are thinking very correctly. So I need to place 7 more cubes to make it symmetric. Which 7 cubes? One here, another here, another here. Then above 4 we need 1. Isn't it? Now all these 8 cubes together makes it symmetric. So what is the electric flux through each cube? Very good. Flux through each cube will become 1 by 8 times of q by epsilon naught. And what is the flux through each face? 64 how, man? Here 3 is there, here 3 is there. 1 by 3 times of 1 by 8.
3 into 1 by 8.
Yes, 1 by 3 times of 1 by 8 times of q by epsilon naught, which will be 1 by 24 times of q by epsilon naught. Got my point? 1 by 3, how it came you are asking? Yes, 1 by 3 came by this logic, Mr. Deva, this logic. I told the logic as, if your charge is kept at one of the vertex, then this is affecting 3 sides of the cube. Check. I will use some other color. Let me use some light color, yellow. Yeah. So if the charge is present in this vertex, then this side, and one and above side. These 3 sides are attached with the charge, right, Deva? How many not attached? 1, 2, 3. This 1, 2 and 3. 3 are not attached. These 3 only will be taken as the faces going to receive the flux. Are you getting my point, Deva? That's why I took 1 by 3. Got it? Is everybody clear with this? If nobody has doubt, then we will proceed further. That is the beauty of Gauss law. These things you can not even imagine by normal phi is equal to E dot dA. You cannot do. So Gauss made us understand the flux more comfortably with the help of Gaussian surface. Got my point? Is it clear to everybody? Again I am
that fourth one.
Saravanan, tell me again, man.
That fourth one I have doubts.
I'll explain it to you. I said that when a charge is present at one of the vertex, so suppose there is a cube like this and the charge is at one of the vertex, okay? I want to make it symmetric. For making it symmetric, how many cubes are needed to make it symmetric? I need to make it symmetric means in the center I want to make it. How I will make it? If I bring another cube here, another cube here, another cube here, now also not symmetric. Above also I need the same layer. So I need 4 more cubes, one here, one here, one here. Now it became symmetric. Are you able to feel it? So since totally I need 8 cubes to make it symmetric, each cube is going to get 1 by 8 times of q by epsilon naught. Is it clear to you?
Yes, sir.
And then For finding of each face, I will check how many sides the charge is located. If I am keeping on one particular corner, then it is going to attach with 3 sides, remaining is only 3 sides. So, I am doing 1 by 3 times of 1 by 8. Understanding, Saravanan?
Yes, sir.
So, this thing, shall we see how the questions can come from here? I will take one CBSE NCERT exercise question itself. So, all of you, if you have the book in your hand, go to exercise question, question number 1.17. Question number 1.17. If you have the NCERT book in your hand, Anshul got the book?
No, sir.
I will open the book in the screen. It will be somewhere in the drive. One day I downloaded, no? They are asking to the face. Ah, then correct, your answer is correct. Yeah, we'll discuss it here. I'm not able to get the internet properly. Yeah. So, this is the question. Those who don't have the book can refer to the screen and you can see this is the question. Now, see how they gave the question. They, without teaching you this concept, they have given the question in the NCERT book. Because actually, you can give they have given a hint. Think of the square as one of the face of the cube. That is the hint they gave. But I taught the concept itself to you fully. Now, pay attention. What they have told? They have told a point charge 10 microcoulomb at distance 5 centimeter directly above the center of a square as shown. What is the magnitude of electric flux through the square? So, imagine if I am drawing, this is the surface of the square and they are telling charge is placed where? 5 centimeter above the square, am I right? If I am taking, this is given as 10 centimeter. So, if I am taking a 10 centimeter cube, that is drawing 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter, 10, 10, 10, 10. Yes, this will become like charge placed in the center of the cube, and charge placed at the center of the cube, you are going to have each face as how much? 1 by 6 times of q epsilon naught, isn't it? I hope you are getting my point. So, the answer for this question will be 1 by 6 times of q is how much? 10 into 10 to the power minus 6, epsilon naught is how much? 8.85 and 10 to the power minus 12. When you solve, you will get the answer. Got my point? Now, this question is okay, clear to us because they have given simple scenario. They may ask you a question like, there is a square face and you have charge present, pay attention, there is a square face, okay, visible to everybody, green color, Online people, visible, right?
Yes, sir.
Yes. So charge is present. This is a 5 centimeter cube, okay, 5 square, 5 centimeter cross 5 centimeter, and I am placing at 5 centimeter height a charge. Charge value is 1 microcoulomb. 1 microcoulomb charge present 5 centimeter above this point, the edge of the square. What is the flux through this face? What will be the answer? 1 16 Anshul or 24? Think properly.
Sir, 24.
24, sir.
5, already I gave 5 Anshul.
Oh, sir, 5, I think 10 centimeters. Sir.
Are you getting my point? If the question would have been the same question, if I were told the height is not 5, it is 2.5, then what will be the answer? 1 by 16 times of? Getting the logic? After you know the concept now, easily you are saying the answer. Because you know, for making it symmetric, I will place how many sides, it will become like condition of charge kept at the edge of the cube, right? If it is 5 centimeter given, then it is a charge kept at vertex of the cube. If they would have given charge is placed from center here and 5 centimeter, then where it goes? Charge placed at edge. If they were told from here 2.5, then it becomes charge placed at face. Are you understanding how the questions can change? For the same square, in this question they kept from center, how much above? It was 10 centimeter, 5 centimeter above. So it became very symmetric scenario. Charge at the center of the cube. If they would have told same 5 centimeter from this vertex, then it will become the case of edge. If from here 5 centimeter, it will become the case of face. If from the here 10 centimeter, it will become the case of the vertex. Understanding the logic? Cylinder. Where? Which place? Suppose I'll talk about. Yes, if cylinder is there and there is charge kept in center of cylinder, then yes, it is q by epsilon naught. If it is kept in one of the faces, I need another cylinder. Correct. So 1 by 2. If you ask kept here, then we cannot solve. But for symmetrics, for example, even if it is a cone question can come.
Sir, what about sphere?
Sphere means where? Already it is q epsilon naught only.
Center?
Center means q epsilon naught only, man.
Okay.
No, then we cannot comment like that. You have to find it.
The cone can be apex of the cone or face of the cone, right?
Face of the cone, not apex. Face only they will. If they give face only, you can solve. Apex they give means you should use some E dot dA logic.
Yes, sir.
That will become complicated. Here you can make it symmetric by keeping another cone, isn't it?
Yes, sir.
So answer will be 1 by 2 times of q epsilon naught. And make q like this symmetric. Huh? No, it will go somewhere this side also, no? Enclose. Don't forget the word. Are you understanding my point now? See, even cube is not there in syllabus. Why are you thinking about cylinder? But this kind of question can come in school. Because very basic question. Cylinder on the top surface or a cone on the face of the cone, circle, right? So you need another cone to make it symmetric. So it will be 1 by 2 times. On the cylinder, 1 by 2 times. But what I have taught this thing, no? It is applicable to competitive classes also. Is it clear to you? Is it clear to you? Sure? Then can you go to the next topic then? Shall I? All of you have written this this part?
Yes, sir.
Even if not, then you can copy from the video later. I will go to the next topic now. Okay? Next topic for today's class is charge distribution. Give the heading as charge distribution. Before I start talking about the application of Gauss law. Charge distribution. Yeah, another hemisphere. It will become 1 by 2 times. Got it? Okay. Now, we are dealing with charges in this chapter. We dealt with 1 charge, 2 charge, 3 charge, 4 charge, 5 charge, isn't it? But in reality, you will never deal with 10, 15, 10, 5, 6 charges. You are going to deal with millions of charges. That is, charge will always be distributed over a length or over a surface or over a volume. Do you agree with me? Charges flow in wire. If you consider wire as a long linear wire, it will be length. If you take thick wire, volume. If you take a surface, then it is the area. So when we deal with charges, we generally don't deal with single, double, triple charge. We deal with multiple charges spread across either length or across surface or across volume. Are you getting my point? So we come to this charge distribution. This is called as linear charge distribution. This is called as surface charge distribution, and is called as volume charge distribution. Also sometimes called as cubic, superficial, these are the names given. Same like your 11th standard thermal properties of matter. Expansion, linear expansion, superficial expansion, cubic expansion, something like that. Linear charge distribution, surface charge distribution, volume charge distribution. And as you are understanding, linear means it will be lambda. Lambda will become equal to dq by dl, that is charge per unit length. Why am I writing dq by dl? Because sometimes you have to use logic of integration for solving the question. And this is given by sigma. Sigma is called as surface charge density, which will become equal to dq by dA, area, isn't it? And this is volume, rho, which is dq by dV. So in simple words, in some books you will also see it written as lambda is equal to q by L, or sigma is equal to q by A, or rho is equal to q by V. But what I have told you is the ultimate logic. So charge per unit length is called as linear charge density, lambda. Charge per unit area is called as surface charge density, sigma. And charge per unit volume is called as volume charge density, rho. What would be its unit? Simple, charge by length, so coulomb per meter. Coulomb per meter square, coulomb per meter cube. Don't you agree? Coulomb per meter square, or coulomb per meter cube. These are the values of or SI units of lambda, sigma and rho. Is it clear to everybody? Because we are going to use this. Now you may ask why you have taught like this. You can write simply q by L, q by A, q by V. No. See, sometimes what they will tell, please pay attention guys. Sometimes what they will tell, if you go some r distance away from it, and they may ask you, what is the electric field at this point? Now, to find the electric field, I'll keep a test charge q0. I know very well it will be having a outward direction because plus is repelling. But how to find that? It is, the formula is E is equal to kq by r square. But we don't know the q value here, the distribution, isn't it? So I'll take a small part which is having charge dq. And we know lambda is equal to dq by dl. So dq will become equal to lambda dl, isn't it? Do you agree with me? So what I will do, I will find the electric field. Electric field will be given by k into dq. Small electric field dA will be k dq by r square. And then I will integrate both sides. Integral of dE from 0 to E is equal to integral of k dq by r square, and we will write dq as what? Instead of dq I can write lambda into dl, isn't it? Do you agree with me? Then we will integrate 1 by r square dl, and we will take the limits from where suppose they have given the value from r1 to r2, then we can integrate and put the values, or maybe L1 to L1, L1 to L2, we can put the values and integrate. This is the reason why I have taught in this way to you. Don't worry, this kind of questions are not there in NCERT, but for your understanding, if question paper is tough, this level of questions can also be asked. Are you getting? But generally, lambda is Q by L, sigma is Q by A, rho is Q by V is enough for you. Charge by length, charge per unit area, charge per unit volume. But this logic, whatever I have taught in this question, don't stress too much about it. It may come if the question is a little complicated. I will talk about that also. First, if you want to write something, please write fast. If you want to write something, please write fast. I am going to go to the application of Gauss law. Can I proceed further?
Yes.
Shall I? So, I am going to talk about the application of Gauss law. Literally the last topic of this chapter. Gauss law's last part, application of Gauss law. There are 3 applications. Again, very important for the board examination and a sure question in your school examination. If you are going to have a nearby school examination, expect a question to come from here for sure, derivation question, where they will ask you, derive so and so, right. So, we will solve one by one. First application we will talk. Write the heading as first application is electric field due to infinitely long straight charged conductor or wire, whatever. This is the heading. Electric field due to infinitely long straight charged conductor. When I use the word infinitely, it means very, very long. Don't imagine infinite means going to space, not like that, very long. Now, everybody drop your pens, listen to me, I will give time for writing. Please pay attention. These derivations you should understand in such a way that for exam also no need of studying, directly you can go for the exam. That level you should understand now itself. Please pay attention, listen to each and every word I am saying. Doubt if you are having, please ask me. So, I am going to take a long wire, infinitely long, okay, and charged also. Charged means I am putting some charge. I can put minus plus as per my wish, like this. And my aim is to find electric field through this wire r distance away from it. Suppose here I am finding the electric field. Are you clear in what I am going to derive now? I am going to take a infinitely long straight charged conductor, and I am going to go r distance away from it, and my intention is to find electric field at this point. Now, I want to use Gauss law because heading itself is application of Gauss law. I want to enclose this wire. What is the best Gaussian surface? Cylinder, obviously cylinder. So, what I will do, for the same length of the wire, infinitely long wire, I will draw infinitely long cylinder in such a way that the surface of cylinder is lying at the point where we are finding the electric field. It became simple now. Why it became simple? Because this particular charged wire is releasing electric field like this. Do you agree with me? Not radially outwards like a bottle cleaning brush. Can you say like that? Electric field pattern. You would have seen, no? For cleaning the bottle we have a brush. If babies are there in home, or normally also in home we are keeping bottles cleaning. One brush is there. That brush will have kuchi outside like this, all direction. Have you seen? That is a pattern of electric field. Am I right? Yeah, for dusting the windows of car also we have something like that. Maybe imagine like that. Yeah. So there is a stick, and from that coming out. I hope you are getting my point. That's how the electric field is. Are you getting how the electrical pattern is? Because I cannot draw on the board. I can draw on two sides. Actually, it is towards you also, away from you also. 3-dimension thing it is. Fine. Now, my intention is to find electric field here. If my intention is to find electric field here, then I am going to use two conditions. See, I will tell the logic to you. There are 3 derivations in this application of Gauss law. In all 3 derivations, I will do what you know. I will find flux by using the conventional formula, phi is equal to E dot dA, E dot A. And then I will find flux by using Q by epsilon naught. And I will relate both, and I will get the answer. Phi is equal to E dot dA I am going to use. Then I am going to use phi is equal to Q by epsilon naught. I will compare both and I will get the answer. This is the logic for all derivations. Logic I told you now. Let us start solving it. Please pay attention. So you know that this cylindrical Gaussian surface will have 3 area vectors. One area vector down, one area vector above, and third area vector in the same direction of electric field. Do you agree with me? As electric field is there, same way area vector is there, same parallel to electric field. Do you agree? This electric field and this area is perpendicular, no flux. This electric field and this area vector is perpendicular, no flux. So possibility of flux is only through one surface, that is a curved surface, and the flux will become equal to E dot dA. So E into A. What is A? A for cylinder, 2 pi RL. 2 pi RL. Length I have taken as L. Length is, let us assume, L. I hope you are understanding this. And cos 0 obviously, because angle between electric field and area is 0 degree. Other two flux is also there, but it is 0. Phi 1, phi 2, phi 3. Phi 1 0, phi 2 0, phi 3 is this much. Agreeing? Also, by our famous Gauss law, I know phi is equal to Q by epsilon naught. And here, since there is a linear charge distribution, I can say that lambda is equal to Q by L. So Q is equal to lambda L. Do you agree? So can I replace Q with lambda L? So it will become lambda L divided by epsilon naught. Equation number 1, equation number 2, from 1 and 2, from 1 and 2. What do we get? E into 2 pi R L is equal to lambda L by epsilon naught. Lambda gets cancelled. L gets cancelled. We get electric field as lambda by 2 pi R epsilon naught. Do you agree with me? Do you agree with me?
Yes, sir.
Okay. One more thing I would like to put here. That is, since we know that 1 by 4 pi epsilon naught is k, if somehow I multiply and divide by 2, it will become like this. It will become, no? I am multiplying and dividing by 2. Why I am doing this? Because I want to get 1 by 4 pi epsilon naught. So it will become E is equal to 2 k lambda by R. That also can be remembered. Both are fine. Do this or do this, both will give same answer. That will save time. One derivation done. Simple. If you understood, please copy fast. Don't take much time. What, Pratap?
The shortcut one, will it turn mass?
Why not, man? But if they mention derivation through Gaussian law, Gaussian surface, then you should do it.
Okay, sir. Yeah.
Yes. Usually this question will be asked in derivation only. Okay, please pay attention, everybody. If anybody has any doubt, feel free to ask me.
Sir, in the first equation, we are taking it as cos theta as cos 0, no sir. Why, sir?
Because electric field and area vector are parallel to each other. How I say that? I said you electric field for this wire is like a bottle cleaning brush, right? How it is you are able to feel it? Electric field direction? Yes?
All directions.
Yes, all directions. And then we are going to have area vector. For this portion, the area vector will be how much? Like this only? Do you agree,
Same direction.
Shakti? Yes, so they are having zero angle between them. I hope you got it, Shakti.
Yes, sir. Yes, sir.
Yes. Please take the notes properly and let me know if you are done with the notes. Yes.
How did you get the simplified formula?
This form? This one or this one? This one.
That.
Yes. I multiplied with 2 and divided by 2. Allowed? Yes. So down will become 4 pi r epsilon naught. Above will become 2 lambda. And 1 by 4 pi epsilon naught is k. So I wrote 2 k lambda by r. Got it, Niranjan? All of you are done? I have 2 more derivations actually, but if I start one more derivation, it will take some time. So I will rest my class here. I may take one more class this week, extra class like how I took last week, because I want to finish this chapter and I want to give some revision to you also, because some of you are going to write exam in the near future and the portion is this chapter. Right, Sriniketan, you have exam. When do you have exam? Monday onwards. What is the portion? Not full chapter. Whatever I taught, it is covered in that. What about Velamal? Coming Tuesday starts. What is the portion for you? First 7? Full. Revan sir, you can stop the live.